Okay, this is our third video dealing with worked examples of radicals and problems that deal with radicals. So let's look at, let's just jump right into it. We got the square root here of 20 times m squared times n to the 5th times p to the 7th. And here this is, I think, easy to deal with if you break it in parts. The square root of 20, we can break that up first. Here, it's the square root of 20. And that gives me, well, 20 is equal to 4 times 5, so I'm going to rewrite it like that. And 4 is a perfect square, so now we go to the square root of 4. 4 times the square root of 5 is the same thing. We haven't changed anything. The square root of 4 is 2. And 2 times the square root of 5 is the same thing as the square root of 20. So we've broken that first part. I'm going to write that out here. 2 times the square root of 5. M squared, that just equals m, because m times itself is m squared. Write that down. N to the 5th, I'm going to rewrite that as the square root of n to the 4th times n. That's equal to n to the 5th because you multiply these two bases of n with different exponents and you add those exponents. So this is a little bit easier to deal with now because the square root of n to the 4th is just n to the 2nd, and the square root of n is still just the square root of n. And we get the square root, n squared, right like that, times the square root of n, and all of this is being multiplied. And then last we have p to the 7th. I'm going to think of that as p to the square root of p to the 6th times p. So square root of p to the 6th is just p to the 3rd times the square root of p. We don't know what that is. And then we'll write that up here. So we have p to the 3rd times the square root of p. So now, what do we do with all this stuff? Well, it's I think, good form to put all the radicals together. Just looks a little bit neater. So the square root of 5 with the constant, the number first, square root of n times the square root of n times the square root of p. And then the numbers that are not in the square roots, right here and here and here. So we get an answer as 2 times m times n times n squared times p cubed. And believe it or not, but we could write our answer like this. Okay, that being said, we can move on to another problem. Let's look at, I should say also we could even neaten this up a little bit more. You might want to write the answer like this: 2m n squared p to the 3rd square root of 5np. Just like that, just to make sure if they give you the answer in this format right here, it's the same exact thing. Okay, so what else can we look at in terms of radicals? Well, what if we had this problem right here? B times the square root of 27a. That 7 is not coming out, sorry. 27a minus b times the square root of 3ab squared. What do we do with this? Well, we could say here that 27 is equal to 9 times 3. So this whole thing is equal to the square root of 9 times the square root of 3a. And we know we can't touch that part, times b. Square root of 9 is 3, so we have 3 times b times the square root of 3a minus, here, the only thing we can really touch is the b squared, and we take the square root of that to get b. That'll come out of the radical sign, and we're already multiplying that by another b, so that's b squared times the square root of 3a. So what do we do here? Well, think of if you had 3x minus x, like that, what would that mean? Well, that would mean 2x. So these two are in fact the same. However, the b is not the same. They're different powers. So what we could do is we could factor out the square root of 3a and then multiply it by 3b minus b squared. And then you might recognize, oh, I I could also pull out, they both have a b here as well. So I can rewrite this as b square root of 3a times 3 minus b. I think we can leave the answer in that form right there. And all I did in this step was to say, what's the common factor between this term and this term? B squared equals b times b, and this equals 3 times b. So in both these terms, we're multiplying by b. So what if I said, well, take that b out of there, right? And then you could go back later and distribute it if you wanted it to see if they're equal. But what you would have left over is just 3 minus b. And this is, in fact, the same exact thing as this radical up here. But this idea carries over. Let's look at, I think, some more straightforward examples on this topic. If I have 4 square root of 3 plus 2 square root of 3 plus, minus 6 square root of 3, what would that be? Minus 6 square root of 3. Well, again, you can think of these as x's and y's if that helps you. If I had 4x plus 2x minus 6x, here I'm just thinking of x as equaling the square root of 3, but it might just be simpler to write it this way. Right? 4x and 2x is 6x's, minus 6x is 0. So in fact, this all equals 0. Building on that idea, we can look at a problem like this. 3 times the square root of 40. What does that equal? Well, the square root of 40 is just 4 times 10. Right? So we can think of the square root of 40 as the square root of 4 times 10. That times 3. Well, that equals 3 times the square root of 4 times the square root of 10. Square root of 4 is 2. So this is 3 times 2 times the square root of 10. So I would get 6 square root of 10, and we're done with that one. And let's just do one more, well, 2 more, no, 3 more. 3 more to finish off this radical video. So what we have, I'm just looking at the sheet, my handwriting is all over the place, that's why I'm not sure how many or more are left. We have the square root of 98 minus 4 times the square root of 8 plus 3 times the square root of 128. What do we do? Let's see, 98. How can we break that down? Again, it's even numbers. I'm going to divide it in 2. When I do that, I would hope to get a perfect square in there. 2 times 49. Well, yes, 49 is a perfect square. Take the square root of that, it's 7. So that's going to help us out. Minus 4 square root of 8, you can think of that as 2 times 4. And then plus 3 times 128. Again, if we cut that in half, we get 2 times 64, and 64 is a nice perfect square. So now we can just break this down. The first component is equal to 2 times the square root of 49. The second component equals 4 times the square root of 2 times the square root of 4. And the third term or component is 3 times the square root of 2 times the square root of 64. All of this, we have 8. Here we have 2. And here we have 7. So now we have 7, combine this term right here, times the square root of 2. Minus 2 times 4 is 8. 8. Square root of 2. 8 times 3 is 24. Square root of 2. So now we can just add these numbers out here and subtract them according to the operation and write that in terms of the square root of 2. So 7 minus 8 is negative 1, plus 24 is 23. So I get for this problem 23 times the square root of 2. And then you never know what they're going to throw at you on these problems. But let's look at one more of this type and then one last one as an important reminder about what's happening with square roots. Next problem, we have 5 times the square root of 8 minus 7 times the square root of 8 and 7 times the square root of I don't like this problem. I can't even read what I wrote there. Sorry. We can make it up, but I want to show you one last problem before I lose your attention completely. So then they could throw a problem like this at you. And at first glance, you want to find, how do I break this down? What do I do? But try and remember another important feature of square roots, which I've gone over in detail in other videos, but the square root of 25, for example, times the square root of 25. Well, what's that equal to? Well, this equals 5 and that equals 5, so doesn't that equal 5 times 5, or just 25? And you might notice that that means, well, the square root of 25 times itself just gives you the number that you're taking the square root of, because really, what are you doing here? You're taking the square root, multiplying it by itself, you're squaring it. You're squaring the square root. So those are inverse operations, so we just get 25. So what does that mean about this problem? That means in this problem the answer is just 110. So look out for that as well in radicals. Alright, so I hope those videos helped. Thanks.